Using the following table of data, assume 2 out of the 24 subjects are randomly selected to answer the following questions. Part A, assume that the 2 selections are made with replacement. Now what with replacement is telling us is that we can treat the selections as being independent from one another. What is the probability that the 2 selections are both group AB and RH negative? That is, in the AB column and in the RH, I said negative, but positive row. So there were 25 people who matched this criteria. We want to know the probability of randomly selecting 2 of them. So since we're able to treat them as independent, we can say the probability of A and B occurring, where A would be the event we pick somebody in this category, and B is the event that we pick somebody in this category. The probability of A and B occurring, since they're independent events, we can say that is the same thing as calculating the probability that A occurs times the probability that B occurs. Well, since they're both 25, to find the probability of each of them, we take the 25 people who are in the category and divide it by the total number of people in this study. That is 224. So if that's the probability that we select that A occurs, the probability that B occurs is the same thing. Now throwing this into the calculator gets us 0.0125. That is the probability that if we pick somebody in this category, A, B, and RH positive, and then put them back into the group, and then pick again, the probability that they're both in the AB category RH positive is 0.0125. Now part B asks a similar question, however, it's asking, assume those 2 selections are made without replacement. Now generally that means we can't treat these as independent. So to calculate this, we have to calculate the probability that A occurs and multiply that times the probability that B occurs given that A has already occurred. So notationally, that is probability of B with the vertical line A. Probability that A occurred times the probability that B occurs given A has already occurred. So we already calculated the probability that A occurs is 25 out of 224. The probability that B occurs given that A has already occurred, now there's only 24 people left in this group since we did not replace the one we chose. So that is, we have 24. And instead of 224 people that we're choosing from, there's one less. So that is 223. Throwing this into the calculator gets us 0.0120. Now you may be thinking the difference between these 2 probabilities in part A and part B is so small, why is it even significant? And the answer is it's not significant. To double check, if we remember, one of the ways to see how significant that difference might be would be to look at, we can use the 5% guideline to see if we can treat these 2 events as independent even though we're sampling without replacement. So if you recall, the 5% guideline says take your sample size, which in this case was 2, divided by the population size, and here we get 0.0089, and since that's less than 5%, we can treat we can treat the selections as being independent even though we're sampling without replacement, because our sample size is so small compared to the population. And in particular, what that means is we'll get a probability that is no different than, or very similar rather, than if we didn't treat them as independent. So to be clear, on part B, I would actually not use the 0.12 answer that we got, and instead use the same answer that we got in part A, because if we treat these as independent, we're asking the same question as we did in part A.